Coming back to you here from the high school, wanted to clarify something in class today that we were discussing that wasn't 100% correct. I came back into class and saw that you guys had been working hard, and you had completed a problem. However, we completed it, and I say we because I was involved in that process too, of letting you go the wrong way. We completed it incorrectly. And then I got to a point where I felt like we were running out of time and just said we'd get to it tomorrow. And we will. We'll come back to it tomorrow. Right up here, this is where we went wrong in subtracting. Subtraction implies decay. And this isn't a decay problem. It's actually a growth problem. You have an investment. If we go back to the original investment, that was growing. So let's go ahead and go back to the original question. The value of a U.S. Treasury bond is now $1,500. Suppose that its value had been growing at a rate of 4% per year for the last 10 years. What's the value of the bond? What was the value of the bond 10 years ago? So it wants to know what it was 10 years ago. There's two different ways to do this problem. The first problem is to read it as is. We want the value of a U.S. Treasury bond is now. And if you remember, whatever's to the left of this equal sign right here, okay, in this case it's A is the amount after T years. So after 10 years, okay, after 10 years, the bond is worth $1,500. So therefore, to the left of the equal sign there, that's where we're going to put the 1,500. P is just the initial amount that we started with, which is what it's asking for. What was the value of the bond 10 years ago? That would be the initial value, the value to start. The rate is 4% growth, and it's been 10 years. So when we plug this into the equation, the growth formula, we see that we must solve for P. We solve for P by dividing by 1.04 raised to the 10th power on each side to get about $1,013.35. When I plug, and I know this is right because when I plug this back into, I plug this back in for P, it should give me 1,500. So I have this up on the calculator. Let's go ahead and do that. I'm plugging this back in for P, so I'm taking this, and I'm going to multiply that by 1.04 raised to the 10th power. And let's see if we get something close to $1,500. Look at that. We get $1,500. So that's how I know I'm right here, because I can plug it back into the equation, and it gives me the desired output based upon what I have. If, however, we plugged 997.248953987 back into the problem, we in fact would not get a correct answer. So I'm going to go ahead and do that for you just to show you here. We take 9, let me go ahead and clear it out, 9, and I'm going to pause it actually and come back with that answer. So I'm going to pause it. Okay, so I've entered that value in, now 997, that very long value. Now I'm going to read it off. I'm going to multiply that now. I'm going to multiply that because remember, I should be able to multiply it times 1.04 raised to the 10th power. 1.04 raised to the 10th power. Does that give me $1,500? And no, it gives me something close to it, but it doesn't give me $1,500. Okay? Had I multiplied that by 0.96, it would have given me something much further off. So again, that's why we got the wrong answer. When I worked it out the night before, I did it a different way. I accounted for that 10 years ago to be negative 10. So in this case, I'm going to go ahead and show you how this comes out as well. So we're going to go ahead and take $1,500, and if we want to know what it was 10 years ago, with a 4% growth rate, right, So 1 plus 0.04 is 1.04, and I entered that mistakenly. Okay, so we're going to multiply that times 1.04, Mr. Claxton. Okay, and that 1.04 is going to be raised to the negative, which that's not negative, the negative 10th power. So the negative, boy did I mess that one up. I'm going to go ahead and pause it. Alright, now that I have that inputted correctly, raised to the negative 10th power, we do get that same value, about $1,013.35. So, again, just wanted to review with you that particular problem and how to find the value 10 years in the past. Thank you very much for watching, and I hope you learned something.